So here we try to find out an equivalent impedance of this network. So this network consists of resistance R, which will have its resistance, an inductor L, which will have its reactance, and a capacitor which will have its reactance. So reactance is the property of inductor and the capacitor to offer their own resistance, and the equivalent resistance consisting of the passives RLC is termed as equivalent impedance. So always remember, whenever there is a L and or C involved in a circuit, you call it an equivalent impedance that you can measure or calculate across the two terminals of this open circuit. You open the circuit and you look from this end to calculate the equivalent impedance Z equivalent. So Z equivalent can be written as, there is a inductor and in series with that a parallel combination of resistance and capacitor is connected. So first we will write the reactance of an inductor, which is ZL, plus in series with that you have a parallel combination of R and C. So R in parallel with ZC, that would be, ZC is the impedance of the capacitor, or say impedance or of the capacitor or the reactance of a capacitor. So now ZL is J omega L and ZC is 1 over J omega C. So plug in these values to calculate equivalent impedance. So it would be J omega L plus, in bracket you have R plus 1 over J omega C. So you can further simplify this expression, and with that you can write the equivalent resistance of this network. So let's say Z equivalent would be J omega L plus, it would be J omega RC plus 1 divided by J omega C. So that's how you can do that. Now you go on simplifying this equation, that would give you the values for your equivalent impedance of the network. So hope you like this video. If you like this video, share with others.